Hello guys, this is Allyson, and today we will be talking about divergent boundaries. Now, we're not talking about the movie Divergent. I just wanted to make that clear, but we are actually talking about divergent boundaries, and I hope this comes to be helpful. Okay, so anyway, let's do this. Alright, so here in this demonstration we have two plates. Now, they could be rough, rigid, so that's why they're not like exactly smooth or anything. So here we have, these here would be convection currents. Those need to be red. Convection currents here. And we'll talk about what those are later on. But for now, let's just say this is lava. And we have two plates moving apart here. So they're going away from each other. Well, what happens then is this lava comes up out of the earth and out. So now we have new seafloor or crust forming here where the lava is coming out. So we have new seafloor forming here or crust, whichever one. So yeah, let's move on. Now, we're going to talk about what geological phenomena may occur at these divergent boundaries. First of all, we have volcanoes, and I'm going to show you how that would happen. So, in the last demonstration, you saw the lava coming out here. And then what actually happens is that lava cools, and over time, it forms this. A volcano, and just like right down here, the lava comes out, and so we have a volcano, sort of like the one, kind of like the one we had last time, and the plates are moving apart, so the volcano could get bigger. And yeah, let's move on. Next, we have earthquakes. Now, this could be fairly confusing, but down here, like right in this area, a lot of pressure is building up. And when that happens, we get motion, and pressure builds up. And as that pressure builds up, we get earthquakes. So, yeah, let's move on. Alright, so you may be wondering where we could find an example of a divergent boundary, and here we have one at the Great African Rift Valley. Now, it's formed by a divergent boundary. It's like right in here, right in that area. It's two of them, but they are formed by these divergent boundaries. One plate is moving this way, one plate is moving this way, the other is moving this way. So now, we will be talking about the Mid-Atlantic Ridge, which is another place where we would find a divergent boundary. You may be wondering, why would that be a divergent boundary? Well, the plates here are moving this direction. They're moving away from each other. And so what we get is this long line, sorry, that was bad, a long line of mountains down here, which form the Mid-Atlantic Ridge. Now, how does this all start? How does divergent boundaries, how do they move? What drives the plates exactly? Well, basically, we have convection currents, and what those are the heating and cooling of magma or lava in the earth. And so what that creates is energy. Sorry, my writing is really bad. But anyway, it creates energy, and that is basically the engine that drives the plates, it makes them move, and so on. Alright, now we'll be talking about the layers of the earth. first of all, we have the crust here. We have the mantle, the outer core, and the inner core. And basically what we'll be doing with these is exploring, just what they are, and stuff like that. So the crust is about 30 miles thick. Not quite sure if that is correct exactly, but it's about 30 miles, I'm pretty sure. The mantle should be, I think it's like 1,802 miles thick. The outer core is 1,400 miles thick, and the inner core is 760 miles. That's a lot. That's a lot of miles. Well, okay. Yeah. Alright, sorry. I was kind of confused there for a second. Alright, let's keep. So, I guess that's it for now. Thanks for watching, and I hope you learned a little more about divergent boundaries.